Exponents review sheet, page 1. We're going to write each expression using exponents and simplify. Okay, so we're first going to write it using exponents. That would be 3 to the third. 3 times 3 times 3 is 27. Now we've simplified. Negative 2 times itself 5 times would be negative 2 in parentheses to the 5th power. Multiplying a negative an odd number of times is going to be negative, and 2 to the 5th is 32, so negative 32. Here, 5 times itself 3 times, 5 to the 3rd, q squared. 5 to the 3rd is 125, so we get 125 q squared. Now here, negative 1 times a times b, that's going to be negative a squared b. No parentheses because it's not negative a times negative a, it's negative 1 times a times a. Okay. Number 2, write 12t to the 3rd divided by 16t to the 5th s in simplest form. For me, I'm going to rewrite that as a fraction first because I think it's easier to see. And I see 12 and 16. Common factor is 4. 4 goes into 12 3 times. 4 goes into 4 4 times. T to the 3rd over t to the 5th. Cancel out 3 t's on top with 3 on the bottom, making that 3 over 4 t squared s. Okay. Evaluate 1/2 times 8 minus 16x if x is 1/4. Evaluate, we're going to substitute in and use our PEMDAS, working inside the parentheses. Negative 16 times 1/4 is going to be negative 4. 8 minus 4 is 4, and half of 4 is 2, positive 2. Okay. Number 4, write 5 to the negative 2nd as a fraction and simplify. So 5 to the negative 2nd, to make that positive, that has to go underneath, which is going to be 1 over 25. Find the product of 6bc and b to the 14th c. So that's exponent of 1, exponent of 1, exponent of 1, 6, b to the 15th, c squared. Remember, multiplying with same bases, keep the base, add the exponents. Okay. Now we're looking here, which expression below has a value of 32? And we're looking all at powers of 4. So I want to realize that 32 is equivalent to 2 to the 5th. That 2 to the 5th is equal to 32. 2 to the 4th is 16, so it's not that one. 2 to the 5th over 2 squared is 2 to the 3rd, which is 8, so it's not that. 2 squared to the 3rd power, power to a power, keep the base, multiply the exponents, is 2 to the 6th, which is 64, so it's not that one. Multiplying with same bases, keep the base, add the exponent, is 2 to the 5th, which is 32. So it is C. Which expression equals 4 to the 4th? Well, let's see. This one, 4 squared times 4 to the 6th, it's going to be 4 to the 8th. Nope. 4 to the 10th times 4 to the 6th, that'll be 4 to the 16th. Nope. 4 to the 3rd times 4 to the 12th, that'll be 4 to the 15th. Nope. Now, B is interesting. Right? You might think, oh, I have to do power to a power. That's going to be 2 to the 8th. But let's instead think, what's 2 squared? 2 squared is 4. So that's really 4 to the 4th. So it is B. Number 8, what is the value of 8 to the 3rd divided by 8 to the 5th? Well, let's take a look at that there. If we think about that, expanding that out, we can cancel the 3 8s up top with 3 8s in the bottom, making it 1 over 8 squared, or 1 over 64. Number 9, write 1 billion as a power of 10. To do that one, I'm just going to really write out a billion. So there we go. There's a billion. Count my zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 to the 9th. On page 2, number 10, which power is equal to 5 to the 4th times 25? We want to be a little creative in our thinking. See how this is a power of 5, 5 to the 4th? We want to realize, oh, 25, that's 5 squared. So that's really 5 to the 4th times 5 squared, which is 5 to the 6th. Oh, that's answer choice B, right? Sort of using our rules to our advantage. Okay. Number 11 is really asking us to do some work with our perfect squares. 13 squared is 169, 14 squared, 196, 15 squared, 225, and 16 squared, 256. And you have a calculator available to you. If you don't have those memorized, you could use your calculator. Okay, number 12. Write out each of the following expressions as a product of factors. Use only positive exponents. That direction, write using a product of factors, that means expand. So we're going to show all the multiplication. So first one here, negative d e squared f to the 2nd power. We're going to start by expanding that outside exponent of 2 where the whole base is negative d e squared f and then times itself. And as you can see, this can be expanded further. So I'm going to show the multiplication here. And then e times f times negative d times e times f. Okay? So I'm going to say that's our answer right there. If you wanted to, you could reorder and put your negative d's next to each other, your e's, your f's. You could also write in a -1 times d there if you wanted as well. Okay? 3gh to the 4th, right? That's just going to be 3 times g times h times h times h. Okay. Then negative 2mn to the -3rd, right? Using only positive exponents. So this n to the -3rd has to go into the denominator, making it negative 2m over n to the 3rd. And then now we can expand. Negative 2 times m over n times n times n. Now we're changing directions. Now our directions are to simplify, evaluate, and write with positive exponents. Now here we can use an expand strategy to see what's going on and simplify, or we could use our rules. It's up to you. You might want a piece of scrap paper if you're going to be doing a lot of expanding. So let's see. 12h squared times 4h squared. 12 times 4 is 48. H squared times h squared, h to the 4th. I mean, if I'm using my rules, that's really the only work I have to show. Okay. Negative 9 fg times 4 f to the 5th g to, oh, maybe I'll put in some of my exponents there. Okay, so let's see. Negative 9 times 4 is going to be negative 36 times 2 is negative 72. F to the 1st times f to the 5th is f to the 6th times f to the 1st is going to be f to the 7th. G times g is g squared times g to the 4th, g to the 6th. Okay. Now 15, negative 12 to the -2nd power. I'm going to first move everything into the denominator. That negative 12 is still going to stay in parentheses, right? Now I think I want to show expanding just so you can see, right, that negative 12 is the base, that's negative 12 times negative 12. So it's going to be 1 over positive 144. Okay. On 16, we have 27b squared d over 12b c to the 4th d to the 3rd. I can see here 27 and 12 have a common factor of 3. 3 goes into 12 4 times. 3 goes into 27 9 times. Now for this one, I'm going to expand so we can see what's going on. b times d times d times d times d times d. Some of the other ones with division I might just visualize, but for our first one, let's expand. Times b times c times c times c times c times d times d times d. Okay? So b's, we can cancel 1b in the bottom with 1b on the top. Our d's, we can cancel the 3 d's on the bottom with the 3 d's on the top. Now I'm looking for what's left over. In the numerator, 9bd. In our denominator, 4c to the 4th. And that's it. 9bd over c to the 4th. On 17, when we simplify, we're just working to get that negative exponent away. That's the only thing we need to fix for our simplifying. So I want to realize the base is m, 7 is that coefficient, so it's not going to move. Only the base and the exponent moves to the bottom. So we get 7 over m squared. Okay. And then 18, negative 12 squared. We want to realize that negative is a coefficient, that it's negative 1 times 12 squared. So negative 1 times 144, which is negative 144. On page 4 here, we're looking to evaluate, which means we're going to substitute in and then simplify. Remember, when we substitute in, we are going to use parentheses. Okay, so I want to look and I want to see, okay, what's going on there, what's getting substituted in. So C is negative 5. So we've got negative 5 times 1/2, B is 1/2, and then A is negative 4 to the 0 power. Now remember, negative 4 to the 0 power is 1. Then that's negative 5 times 1/2 times 1. That's going to be negative 5 over 2, or negative 2 and a half. On 35, we got to be careful, got some exponents there. So negative, now I substitute in for A, negative 4 squared, minus, now I substitute in for C, negative 5, plus 1/2 to the 0 power. Now we want to point out here, cannot combine that double sign. That's really negative 1 times negative 4 squared. Negative 4 squared, negative 4 times negative 4 is positive 16. Here we can combine that double sign because that's negative 1 times negative 5, which would be positive 5, and then that 1/2 to the 0 power is just 1. So really negative 16 plus 5 plus 1 is negative 10. And then we've got 16, substitute in for B, which is 1/2. Negative 5, substitute in for C, which is negative 5. Exponents first, 1/2 squared. I always like to write out when I have fractions just so I can see it. That's 1/2 times 1/2, which is 1/4. So that's going to be 16 times 1/4 minus 5 times negative 5. 16 times 1/4, 4 goes into 4 once, 4 goes into 16 4 times. So that's going to be 4. And then negative 5 times negative 5 is positive 25. So we add them together and we get 29, positive 29. On number 37, we're going to simplify the following using our law of exponents. So it's just a way to write down what's happening. Y to the A plus Y to the A, right? They both have coefficients of 1. That's going to be 2Y to the A, just adding like terms there. Y to the A times Y to the B, keep your base, add your exponents. Y to the negative A, 1 over Y to the A. Y to the AB, keep your base, multiply your exponents. Y to the A times B. Y to the 0 power, just 1. Division, keep your base, subtract your exponents. Okay. 38 and 39 are explanation questions. So you can have different answers here. There are different explanations that would be accepted. For 38, determine if 3 squared to the 3rd power is equal to 9 to the 3rd. One of the things I want to realize is that 3 squared is equal to 9. So 3 squared to the 3rd is really just 9 to the 3rd, which is 9 to the 3rd. So I'm just going to say, you know, the expressions are equivalent. Okay. Then we have 39. Explain if the following expressions are equivalent. 9x squared plus 9x squared and 9x squared times 9x squared. So it's really saying are adding these and multiplying these the same thing. Okay. So I want to show that 9x squared plus 9x squared is equal to 18x squared. So we're just adding like terms here. But 9x squared times 9x squared is really saying 9 times x times 9 times x, which will be 81x to the 4th. Right? And 18x squared is definitely not equal to 81x to the 4th. So we can say the expressions are not equivalent. Okay? And I took more of a symbolic approach. If you're better at explaining in words, you could do that. Numbers 40 and 41 are explanations. Again, your explanations and your examples you give are going to vary from person to person. This is how I think about it and look at it. So just to give you an example of it. Is 3 to the 6 plus 3 to the 6 greater than 3 to the 12th? Explain why or why not. Give an example of an expression equal to 3/12. So we want to kind of a lot going on there. First, we got to figure out, is 3 to the 6 plus 3 to the 6 greater? So let's think about what 3 to the 6 plus 3 to the 6 is, right? Those are like terms. So when we add them together, essentially we're saying we have two groups of 3 to the 6th, right? So if I think of that, I can express that as 2 times 3 times 3 times 3 times 3 times 3, right? 2 times 3 to the 6th. But 3 to the 12th, right? That's as if we took a 3 to the 6th and multiplied it to another 3 to the 6th, right? So that's 3 times 3 times 3 times 3 times 3 times a 3 times 3 times 3 times 3 times 3 times 3. That's going to be way bigger than a 2 times 3 times 3 to the 6, right? You're multiplying it by a whole nother one. So in my explanation, I'm going to say, 3 to the 6 plus 3 to the 6th is not greater than 3 to the 12th, because 3 to the 6 plus 3 to the 6 is equal to 2 times 3 to the 6, which is 2 times 3 times itself 6 times, whereas 3 to the 12th is 3 times itself 12 times. So that's going to be way bigger. So then to give an example, the expression 3 to the 6th times 3 to the 6th would be equal to 3 to the 12th. Okay, so I did that example part, got that. And just to sum up my explanation, I'm going to say that the sum of 3 to the 6th and 3 to the 6th is smaller than the product of 3 to the 6th times 3 to the 6th. Okay. All right. Let's go to 41. Peter says that 6y squared plus 6y squared is the same as 2 times 6y squared. Explain whether Peter is correct. Use numbers to support your explanation. Okay, so using numbers, that means we're going to have to kind of make up a value for x to use numbers to support our explanation. So first thing I want to look at is that 6y squared plus 6y squared, right? Combine those like terms, that's 12y squared. Well, what's another way to get 12y squared? Well, 2 times 6y squared, right? 2 times 6y squared, multiply your coefficients, is 12y squared. So they are the same. So let's pick an example. We could pick a value of y of 1, of 2, of 3. I'm going to say let's make things simple but interesting. Let's let y be 2. Okay? So we're going to look to see, are they the same? So on one side, I'm going to have 6y squared plus 6y squared, and on the other, 2 times 6y squared. And we're going to look to see, are they equal? So let's substitute in for y. Okay, and we'll simplify, right? 2 squared is 4. Right, and then 2 times 6 times 4. 6 times 4 is 24. 24 plus 24 is 48. 2 times 24 is 48. So they are equal. We've proved it. So we could say, yes, Peter is correct. 6y squared plus 6y squared is equal to 2 times 6y squared. Okay, and just kind of restating my work. Showing both sides. Thus, right? Thus is a big math proof, big math explaining word. Thus, therefore, hence. If you do college math and you're writing proofs, you'll use that a lot. I forgot my 6. Right? When y equals 2, both expressions have a value of 48. Okay? Now again, your explanation might be a little different than mine, and that's great. It can still be a great explanation. So we've done a few explaining problems as practice. Yes, you can expect to see one explaining problem on your quiz, just really looking to show you have a foundational understanding of our exponents. Page 3, we're still simplifying, writing using only our positive exponents. Number 19, we've got power to a power, 3x to the 6th, z to the 5th, all raised to the 3rd power. We can go ahead and just use our power to a power rule and multiply our exponents. And then simplify that 3 to the 3rd, which is 27. Or we could have gone ahead and expanded that first step and then sort of just done our multiplying with same bases. Either way, we get to the same answer. It's up to you there what steps you want to take. Number 20 with the division, I always like to go and write as a fraction so I can see what's going on. Now, r to the 30 in the denominator, there is no way I'm expanding that and writing r 30 times. No way. So I'm just going to kind of visualize it. I've got 6 w's on top, 2 on the bottom, means I can cancel 2 w's, leaving 4 left over on the top. So in our numerator, w to the 4th. And then our r's, I can cancel 8 r's on the top with 8 r's on the bottom, leaving 22 r's on the bottom. So we get w to the 4th over r to the 22nd. Okay. Now 21 here, we've got negative 15 to the negative 2nd power times negative 15. So that means, well, this has got to go into the bottom. So that's 1 over negative 15 to the 2nd times negative 15. So negative 15 over negative 15 squared, which would be negative 15 over negative 15 times negative 15. So we can cancel out one of those negative 15s on the top and the bottom, making this 1 over negative 15. Or if you're like me and you prefer that negative on top, put it on top. 22, ooh, finally we've got some 0 exponents. 14m to the 0 times 14m to the 0. The difference there is the parentheses. The 1 with the parentheses, the whole thing becomes 1. 14m to the 0, that's 14 is a coefficient, right? It's 14 times m to the 0. Only the m becomes 1. So we have 14 times 1 times 1. So our answer is 14. On 23, we've got some negative exponents there, some coefficients to reduce. I'm going to start with those coefficients, otherwise I forget. 3 goes into 12 4 times, 3 goes into 15 5 times, and now we want to move our negative exponents. Sometimes I like to circle them so I can see which ones have to move, and I'm just going to move them. So we've got 4 p to the 7th, and then that p to the 3rd moves up. over 5. Ooh, I forgot to move up the k to the 5th. K to the 5th, and then 5 over k squared. Now I'm going to combine those same bases. That's going to be 4p to the 10th, k to the 5th over 5k squared. Now 2k's on the bottom can cancel with 2k's on the top, leaving 3. So it's going to be 4p to the 10th, k to the 3rd over 5. Okay. On 24, we've got multiplying with same bases and a power to a power. We've got to work with that power to a power first. So we've got 10xv times, that's going to be 3 to the 3rd, x to the 9th, v to the 12th. So 10xv times 27, x to the 9th, v to the 12th. 10 times 27 is 270. X times x to the 9th, x to the 10th, v times v to the 12th, v to the 13th. Okay. Number 25, we've got that power to a power. We can use our rule or we can expand there. I'm going to expand here. Just feel like it. So 9 times 9 is 81. H to the 3rd times h to the 3rd, h to the 6th, m squared times m squared, m to the 4th, and k times k. K squared. Now 26, kind of throwing a curveball in there. Look, we're adding, we're not multiplying. Right? They're like terms, r squared, 13r squared plus 3r squared, 16r squared, that's it. Okay. Now 27, we've got some more going on here. We've got 0 exponents, some negative exponents, coefficients. Start with my coefficients. 15 goes into 15 once, 15 goes into 45 3 times. That e to the 0, that's going to be 1, so 3 times 1, 3. And then we got to move that f. That's what I'm going to start with. So in the numerator, 3g to the 3rd over e to the 5th, f to the 4th, then we move that f down, g to the 3rd. Let me combine here. 3g to the 3rd over e to the 5th, f to the 5th, g to the 3rd. The g to the 3rd over g to the 3rd cancels out, and we're just left with 3 e to the 5th, f to the 5th. Now, 28 through 33, different directions. Compare. We're going to use greater than, less than, or equal to. So we have to somehow figure out what's going on with these values. Now here, 28, negative 5 to the 4th, negative times 5 to the 4th. It's really looking at what's going to be positive, what's going to be negative. Here, a negative times itself an even number of times. That's going to be a positive number. Here, it's going to be a negative. They're both 5 to the 4th, so I know the 5 to the 4th that's positive is going to be larger. If you use your calculator, you can find, to be certain, this one's going to be positive 625. This one's going to be negative 625. Okay. Here, we're looking at 9 to the 0 is 1 times 9 to the 5th, so it's just going to be 9 to the 5th. These will be equal. 3/4 squared, 3/4 times 3/4 gives us 9/16. Here with the negative exponent, we have to flip. So 4/3 squared is going to be 4/3 times 4/3, which is 16 over 9. Ooh, that's greater than 1, less than 1. So there we go. 3/4 squared is less than 3/4 to the negative second. Okay. On 31, 6 to the 7th times 6 squared, that's 6 to the 9th. Well, 6 to the 9th is less than 6 to the 14th. 6 to the 3rd plus 6 to the 7th. Oh, addition. You can't combine those, right? So 6 to the 3rd, that's 6 times 6 times 6, plus 6 times 6 times 6 times 6 times 6 times 6. 1, 2, 3, 4, 5, 6. 6. Okay? 6 to the 10th is all those being multiplied. With the addition here, that's going to be less than 6 to the 10th. Okay? Because that's 6 to the 3rd times 6 to the 7th, right? Multiplication makes larger faster than addition. Here we're looking at our power to a power rule. That'll be 3 to the 20th. Ooh, this one will also be 3 to the 20th. So they are in fact equal.